You'll see why in a little bit. It says a nation that is afraid to let its people judge the truth and falsehood in an open market is a nation that is afraid of its own people. Because you're going to have to, the reason why this quote is relevant is you're going to have to judge the correct equation and judge the truth and falsehood of a particular statement. The learning goals. The students will be able to pick the proper equation to solve a kinematics problem. You now know four kinematics motion equations, all that are missing one variable. You need to be able to pick the correct equation for a given situation and be able to solve it for an unknown. And you should understand the relationship between the five kinematic variables and the equations. So we start off with the idea of the motion equations. The first thing is that we have these motion equations, but which one do we use? So I may have something in which I'm trying to solve for acceleration. Well, I have acceleration here, here, and here. So which equation do I use? Because all of them have acceleration. These two don't even have to be rearranged to solve for acceleration. So the question is which one do you use? If you take a look at the kinematics variables, we have five of them. They are initial velocity, final velocity, displacement, acceleration, and time. Okay, collectively, these are known as Ifdat, because you see initial, final, displacement, acceleration, and time. So Ifdat, it's an easy way for you to remember. It's an acronym that allows you to figure out which variable is which and then go from there. Now, if you look, of the four kinematics motion equations that we have, all of them are missing one variable, and they all have a different variable they're missing. So, if you were to look, there is no final velocity in this equation. No final velocity. There is no displacement in this equation. There's no acceleration in this one, and there's no time in this one. If you notice, you always have to know the initial velocity. So you're always going to have to solve for that no matter what. If you're not given the initial velocity, you're going to have to solve for it first. A lot of times, you'll have to solve for the initial velocity first and then plug it into a new situation. But you always have to know the initial velocity. In order to pick the right equation, the first thing you need to do is you need to read the question. I know that seems pretty obvious, but a lot of people miss that. You read the question, you circle the goal. So how long will it take? So that lets me know that I'm looking for time. You always want to circle the goal. What am I trying to reach? Then you underline keywords and information. So a keyword would be rest. The reason why a keyword rest is because it indicates the initial velocity is 0. Then you also underline the numbers and the units that go with those numbers. Now, you may not be able to tell from the wording. It says to be accelerated from 60 meters per second. So this right here may indicate to some people that this is acceleration. But if you know the units, you know that can't possibly be right. Instead, it has to be a velocity. So if I knew this was an initial velocity, then that has to be final velocity. And you know displacement is measured in meters. So by underlining the keywords and information, it allows you to figure out what information you're given. The second step is to match the units like we talked about. You match the units. Units are the key to finding given information. The only two things that have the same unit are the initial and final velocities. So at that point, you have to be real careful. You've got to say, okay, which one is initial and which one is final by reading the question. But other than that, you should be able to figure out just by looking at the number and the unit that goes with it what it is. So we've already assigned our given information from the previous question. So we said initial velocity, final velocity, displacement. Now, one key thing that you're supposed to do is whatever you're trying to find, remember how long, you assign a question mark to. So now if you were to look at this, there's only one thing that doesn't have a number in our given information. Okay, it doesn't have a number or a symbol, so I'm not trying to find it, and it's not a number that I'm given. This right here will determine what our equation is. So this right here is something that we don't have anything of. And if you look at this equation, I can plug in the initial velocity. I can plug in the final velocity. Get those backwards. Initial velocity and final velocity. I can plug in the displacement, and that would just give me one variable to solve for, and that's time. So this right here, the fact that what you don't have, what you have nothing for, determines the equation. So this is simplified by the mnemonic Ifdat, initial, final, displacement, acceleration, and time. This example says Usain Bolt accelerates from rest to 44 miles per hour, and he does that in 40 meters, and then continues at 44 miles per hour for the rest of the 100-meter race. So now the question says, how long does this entire race last? And so what we need to do is we need to say, okay, let's first start off by seeing what we know about this race. It tells you that Usain Bolt is going to accelerate from rest to 44 miles per hour in 40 meters. So we know that 40 meters he's going to be accelerating. Then we also know that he's going to be moving at a constant velocity for the rest of the 60 meters. He's going to maintain this 44 miles per hour. So we know that the total 100-meter race is going to consist of two different segments. And what we want to know is we want to know the total time. So we'll put it in another color. We want to know the total time of the race. So let's break it up into two different segments. Let's break it up into the accelerated motion and the constant velocity motion, and then let's add those two times together. So in both cases here, I'm going to be looking for time because that's going to allow me to get to my goal of time. Now, one of the key things that we can do here is we can say, okay, for the 60-meter part, it's going to be really easy to determine the overall time because we have constant velocity. Whenever we have constant velocity, we can use the equation v equals delta d over t. So it's a really easy equation to use. We know the displacement. The displacement is going to be the 60 meters. We know the velocity is 44 miles per hour, but we can't use 44 miles per hour. Instead, we have to convert it so that we have a 19.6 meter per second velocity. That's how you convert 44 miles per hour into meters per second. You should be familiar with that by now. So now we can plug our numbers in and we can say 19.6 equals 60 divided by delta t. When you take 60 and you divide it by 19.6, you end up with something around 3.06 seconds. So that right there is the time that it takes him to move 60 meters in constant velocity. Now you should realize that it's going to take probably a little bit more time to do the first part of the race because he's starting off with an initial velocity of 0. Because it says he starts off at rest, we know the initial velocity is 0. We know that the acceleration is not given to us. We do know that the displacement is 40 meters. And we do know his final velocity. Remember, his final velocity is going to be the same 19.6 that he reached. So now we have our four things that we're looking at. We have our Ifdat. The acceleration is the only thing that we don't have. So we choose the equation that doesn't have acceleration in it. And that's delta D equals 1/2 VF plus VI delta T. Or in this particular example, it would be 40 equals 1/2 19.6 plus 0 times delta t. 19.6 plus 0 is still 19.6. Divided by 2 is going to give you 9.8 delta t. So when you take 40 and divide it by 9.8, you end up getting your time for the accelerated phase, which is 4.08 seconds. So now remember the question said to find the overall time. So if it takes 4.08 seconds to do this, and it takes 3.06 seconds to do that, the total time can be found by adding those two numbers together. And when you add those two numbers together, you would get something like 7.14 seconds. Okay, on this next question, we see a jet fighter takes off from a 120-meter runway. It says the plane starts from rest and accelerates, I should say 3.4 seconds before taking off. What is the acceleration of the jet? So now you would say, okay, delta D equals 120, delta T equals 3.4, and we know the initial velocity is 0. So now we want to know what the acceleration of the jet is. If you take a look here, we do our Ifdat. The only thing that we don't know, we've got initial, displacement, acceleration, time. The only thing that doesn't have something is final velocity. So we say, okay, what equation doesn't have final velocity in it? And that would be the equation delta D equals VIT plus 1/2 AT squared. Now remember, when the initial velocity is 0, this entire term right here cancels out. So what we're left with is delta D equals 1/2 AT squared. So we plug in our numbers. 120 equals 1/2 a, which is what we're trying to solve for, and then our t term is 3.4 squared. So the first thing we need to do is we need to combine these terms right here. So I'm going to take 3.4 and square it, and then divide it, or excuse me, multiply it by 1/2. So when you do 3.4 times itself, you get 11.56. You divide it by 2, and you get 120 equals 5.78a. Divide both sides by that 5.78, and when you do that, you should get your acceleration to be something along the lines of 20.76 meters per second squared. Okay, you should be able to work out example A3 entirely on your own and come up with the displacement of 20.4 meters. Remember to follow the steps that we've discussed in this video, including lining up your given, figuring out what you know and what you don't know, and how to pick your correct equation.